Hi, I'm Bob. In the last video, we discussed the nature of econometrics and economic data. Econometrics applies various specification and estimation methods to economic data. We try to estimate the causal relationship between variables, test economic theories and ideas, forecast economic variables, and evaluate public policies and programs. We deal with observational data or non-experimental data in econometric analysis. Today, let's solve the problems at the end of Chapter 1, the nature of econometrics and economic data, in Professor Jeffrey Wooldridge's textbook, Introductory Econometrics, a Modern Approach, 7th edition. Here's the first question. Suppose you are asked to conduct a study to determine whether smaller class sizes lead to improved student performance for 4th graders. If you could conduct any experiment you want, what would you do? Be specific. Recall that in social science, we could rarely run an experiment, mainly because of ethical concerns. If I could conduct the experiment, I would randomly assign the students to classes of different sizes. I would order the students by their last names, and then assign them to a small size class and a large size class one by one. The most important thing is that we should not choose students based on their characteristics, like gender, race, learning ability, and family background. Suppose we have 20 small-sized classes and 10 large-sized classes. We could compare the average scores between the classes and see whether smaller class sizes lead to better student performance. The second question is, more realistically, suppose you can collect observational data on several thousand 4th graders in a given state. You can obtain the size of their 4th grade class and a standardized test score taken at the end of 4th grade. Why might you expect a negative correlation between class size and test score? Here's my answer. A negative correlation means smaller class sizes are associated with higher test scores. It suggests that a smaller class size leads to a higher test score. Here's the third question. Would a negative correlation necessarily show that smaller class sizes cause better performance? Explain. No, a negative correlation does not necessarily show that smaller class sizes cause better performance. Many other factors could affect students' test scores and performance. A student's ability could influence her test performance. If smarter students are assigned to small-sized classes, the higher test scores may be attributed to students' ability. The teacher's teaching ability and experience could affect students' performance too. Family background also plays a role because wealthy families are more likely to invest more in their children's education. Children could inherit their parents' patience and diligence, and therefore have better academic performance. If the small-sized classes have more students with better family backgrounds, the high test score in small classes may be due to better family backgrounds rather than the class size. So, without a random assignment, we have to control other variables and factors by adding those factors to the model or using estimation methods to alleviate the problem. Let's go to the second problem. A justification for job training programs is that they improve worker productivity. Suppose you are asked to evaluate whether more job training makes workers more productive. However, rather than having data on individual workers, you can access data on Ohio manufacturing firms. In particular, for each firm, you have information on hours of job training per worker training and the number of non-defective items produced per worker hour output. The first question is, carefully state the ceteris paribus thought experiment underlying this policy question. The ceteris paribus effect means to hold all other factors constant. If all the workers are randomly assigned to the job training programs, the other factors, such as the workers' ability and characteristics, are also randomly distributed among workers who received training and those who did not. In this case, we don't need to worry about other factors. If we find that the training hours are positively correlated to the number of non-defective items produced per worker hour, we could conclude that job training improves workers' productivity. The second question is, does it seem likely that a firm's decision to train its workers will be independent of worker characteristics? What are some of those measurable and unmeasurable worker characteristics? No, the firms often train workers based on their characteristics, such as educational attainment and years of experience. For example, new workers with zero work experience are more likely to receive job training than older workers. Some measurable worker characteristics include age, gender, race, educational attainment, years of job experience, and marital status. Unmeasurable characteristics include the worker's ability and the worker's personality. Whether a worker can learn a new skill quickly, whether she's patient, or whether she's lazy could affect her job performance, but we could not measure them directly. The third question asks us to name a factor other than worker characteristics that can affect worker productivity. The work environment can affect worker productivity. A clean and pleasant environment helps improve productivity. Technology also affects workers' productivity. The fourth question, if you find a positive correlation between output and training, would you have convincingly established that job training makes workers more productive? Explain. No. According to above analysis, many other factors, influence worker productivity besides job training. The estimate will be biased if we do not add them to the model as control variables. The high output may be due to other factors. These variables may be difficult to measure or collect. We must use various econometric approaches to tackle the problem. Now let's look at the SIR problem. Suppose you are asked to find the relationship between weekly hours spent studying and weekly hours spent working. Does it make sense to characterize the problem as inferring whether study causes work or work causes study? Explain. No, it does not make sense to say study causes work, or vice versa. A causal relationship means a cause leads to a result. The cause and the result are linked by underlying economic theories or reasoning. In this problem, work hours and study hours are likely to be negatively correlated, but it is just because the sum of them is fixed for many people. Finally, let's solve the fourth problem. States and provinces that have control over taxation sometimes reduce taxes in an attempt to spur economic growth. Suppose that you are hired by a state to estimate the effect of corporate tax rates on, say, the growth in per capita gross state product, GSP. The first question is, what kind of data would you need to collect to undertake a statistical analysis? The tax rates and the GSP are the variables we want to estimate the relationship. We should at least collect each state's tax rate and per capita GSP. If other factors that affect GSP are not randomly distributed among the states, we should also collect those factors. The second question, is it feasible to do a controlled experiment? What would be required? Because of ethical concerns, it's not likely to undertake a controlled economic experiment like the one in natural science. But we could add many control variables to the model to capture the effects of those control variables on GSP. Such control variables could be each state's average technology, consumption, and investment. After controlling these factors, the estimate for the tax rates will be the ceteris paribus effect of tax rates on GSP growth. Here's the third question. Is a correlation analysis between GSP growth and tax rates likely to be convincing? Explain. It's not convincing. Only the correlation between GSP growth and tax rates could not conclude a causal relationship between them because omitted variables in the model lead to bias. We should use economic models, specification strategies, and estimation methods to find the causality between GSP and tax rates. Thank you very much for doing the exercises with me. See you next time. Thank you for watching this video and subscribing to my YouTube channel. See you next time.